In this example, we have a platform inclined by a few centimetres at one end. We have 4 identical jars, but they're filled with sugar. This one fully, this one 2/3, this one 1/3, and this one completely empty. We might wonder at the outset whether a heavy one and a light one would roll at the same rate. So we position them at the top of the ramp and let them go at the same time, and they roll at the same rate. Perhaps there was a delay in the starting of one of them. We then consider whether or not one heavier and one light will always finish at the same time. So we position the 1/3 and 2/3 at the top of the ramp and let them go to sea. And the surprise is that one completes the journey, the heavier one, the other one stopped. And there's no glue on it, it's just sitting there but refusing to go. When we show what's inside the jar and see that the sugar inside it is, as the jar rotates, creating a sort of an avalanche effect, we can see how a braking mechanism is developing. And when 2/3 full, the braking mechanism is insufficient to stop the rolling jar, but in the case of the 1/3, the lower centre of gravity of the sugar inside it gives rise to a more effective braking mechanism. Now that we know that rolling objects roll down hills, we can look to see a larger rolling object and see that it does the same. But surprisingly, it doesn't. Students quickly realize that there is a concealed weight inside. In this instance, some magnets positioned near the rim and situated beyond the fulcrum is sufficient to ensure that the drum rolls up the hill.